Assalamualaikum students, hoping you all fine. I am here with the 9th program of calculus of BSCS level. Today's program will be about domain and range of a function. As all of you know that we have been studying functions since our last two programs, so before going to today's program, I shall give you a brief summary of last programs of functions. In our last program on functions, we studied operation of function, graphs of function, graphing functions by translation, graphing functions by reflections, and graphing functions by scaling. Then a vertical line test of function, and finally even and odd function. As I told you that today's program would be about domain and range of a function and different techniques to find out domain and range. In today's program, we shall study domain, range, domain determined by physical or geometrical consideration, domain determined by natural restriction, domain determined by spatial restriction, then some techniques to finding out range, and finally the piecewise function. In many situations, the independent variable of a function is not free to vary arbitrarily, rather it must be restricted to lie in some set. That would be considered as domain. You can see the definition of domain on the screen. Domain is the set of all allowable values for the independent variable x. Now we move to range. You can see the definition of range on the screen. Range. If x is a number in the domain of a function f, then the number f of x that associates with x is called the value of f at x or image of x under f. Or more simply, range is the value of y for each x value. To understand the concept of domain and range more clearly, we would consider a numerical example. You can see that example on the screen. If we have a function f of x is equal to x square, or more simply y is equal to x square. Now if we put x is equal to 2, then f of 2 would be equal to 2 square, or finally y would be equal to 4, where if domain is 2 for this certain example, the range value would be 4. Then if we put x is equal to 3, so function become f of 3 is equal to 3 square, or finally the function value or y is equal to 9, which shows that if we have domain is equal to 3, so range would be equal to 9. Now we can simply define domain and range. You can see the definition of domain and range more clearly or more simply on the screen. Domain is a set of all possible values of independent variable, and range a set of all possible values of f of x as x varies over the domain of f is called range. Now we will consider some methods to determine domain from different cases. The restriction on independent variable that determine the domain of a function generally comes out in one of the three ways. You can see all these three ways on the screen. The first one is physical or geometric consideration, which would determine domain. The second restriction would be considered as natural restriction. The third type of restriction which would determine domain would be spatial restriction. Here we will consider the very first method, which is physical or geometric consideration, which would be helpful in determining domain. You can see in figure an example to determine the domain by physical or geometric consideration on the screen. If we consider a square figure which is having length of 10 cm on each side, so by cutting an x value on each side, we get the final function equation as y is equal to 100 minus 4x. Subtraction of x or the cutting of x on each side of the square would be considered as physical consideration or physical restriction. So through this method we get domain is equal to x such that x is greater than or equal to 0 and less than or equal to 5, or more simply domain for this function, which is y is equal to 100 minus 4x, would be equal to 0 and 5. Means this function equation is defined on every value between 0 to 5, but not more than 5 or not less than 0. For another example which would be helpful in determining the domain by geometric or physical consideration, we have another example which you can see on the screen. We have an example which shows that it costs 12 cents to manufacture a certain kind of computer chip. Here the formula of the cost to manufacture a computer chip would be considered as f of x is equal to 0.12x. For the solution, if we consider physically, then x must be a non-negative integer. So domain becomes x such that x is equal to 0, 1, 2, 3 and so on, where all the x's would be considered as positive or non-negative integers. So finally, for the function f of x is equal to 0.12x, domain would be 0, 1, 2, 3 and so on. Not all the functions which we have studied in mathematics arises from physical or geometrical consideration. Many are purely mathematical objects. For such functions, there are no physical or geometrical restriction in independent variable. So then we use natural domain, which arises naturally or from some formula. So natural domain can define more simply, which you can see on the screen. Natural domain is the domain when there is no physical or geometric restriction, but some restriction can arise from some formula or naturally. Here we will consider an example which would be helpful to determine domain naturally. You can see that example on the screen. If we have a function which is f of x is equal to 1 divided by x minus 1 into x minus 3. It's quite clear that the function is not defined if x is equal to 1 or x is equal to 3. If we show the solution set on a real line, so the solution set we have for this example is minus infinity to 1, union 1 to 3, union 3 to infinity. So finally, the natural domain would be f of x is equal to 1 divided by x minus 1 into x minus 3. Domain would be all the numbers except 1 and 3. Natural domain can be defined more simply, which you can see on the screen. If a function is defined by a formula and there is no domain explicitly stated, then it is understood that the domain consists of all the real numbers for which the formula makes sense and the function has a real value. Here a point is to be noted that formula should make some sense and it should be having all the real values, not any imaginary number or not any imaginary value. For the explanation of this definition, you can consider an example which you can see on the screen. If we have a function f of x is equal to x square and we have to determine the domain for this function, so for the solution we consider that the formula f of x is equal to x square makes sense and it yields all the real numbers or it yields all the real values for x. So natural domain for this example between minus infinity to plus infinity. Another example for natural domain is if we have a function g of x is equal to 2 plus under root x minus 1. We know that g of x is not defined for x less than 1. So the natural domain for this function would become 1 to plus infinity, where 1 would be included in the domain. Now the third way to determine domain is by spatial restriction or artificial way. Restrictions often used to focus on certain values of independent variable that may be of spatial interest in the given problem or situation. Domain determined by spatial restriction. Sometimes it is desirable to limit the domain of a function to some subset of its natural domain by imposing specific restriction on independent variable. So the domain which would be determined through this way would be considered domain determined by spatial restriction. To understand the concept of domain determined by spatial restriction more clearly, we can consider an example. If we have a function f of x is equal to x square and that is restricted by some condition which is x greater than or equal to 0 but less than or equal to 1. So for this spatial function f of x is equal to x square, our natural domain with restriction would be 0 and 1, both number inclusive, but the natural domain without restriction would be minus infinity to plus infinity. Now if the domain is restricted by some values, so then we cancel the common factor and then we define the domain. For the explanation of this statement, you can consider an example which is on the screen. Domain determined by spatial restriction. If we have an example, h of x is equal to x square minus 4 divided by x minus 2. We know that this function is restricted for a value 2. So for that we would open the formula in the numerator as h of x is equal to x plus 2 into x minus 2 divided by x minus 2. Now the common factor which is x minus 2 in the numerator and denominator would be cancelled out. So the final expression for this function become h of x is equal to x plus 2. Now we know that for this specific function which was given in the example, domain was all the values excluding 2, but the natural domain without restriction would be minus infinity to plus infinity. Now we will consider some techniques to find out range. We simply find out range by putting the values of x or the values of domain in the function which results into the value of dependent variable which are called range. Here we will consider an example to find out range which you can see on the screen. Techniques for finding out range. Here we consider an example where the function is f of x is equal to x square. We know that the natural domain for this function is minus infinity to plus infinity. Now by putting all the values from minus infinity to plus infinity in this function gives you all the positive values. So the range would be equal to 0 to plus infinity or all the non-negative integers. If we consider the second function which is g of x is equal to 2 plus under root x minus 1, we have considered natural domain for this function which was 1 to infinity. Now by putting all the values from 1 to infinity in this function, we will get the range. If we put 1 in this function, we get 2 plus under the root 1 minus 1 which would become 0. So g of x would be having a single value which is 2. So natural domain for this become 1 to infinity. So final range for this example for this function is 2 to infinity, where 2 is inclusive in the range and 1 is inclusive in the domain. As I told you that simply we can find out range by putting the values of x or the values of domain in the function which results into range. Here we will consider another way to find out range which is by natural domain method. You can see an example on the screen. If we have a function which is x plus 1 divided by x minus 1, for this example natural domain is equal to all the values of x except 1, because if we put 1 in this function it would make the denominator 0 and the function results in infinity which does not exist. Now to find out range for this function, we consider y is equal to x plus 1 divided by x minus 1. Now we will multiply both sides of the equation by x minus 1. By simplification we get xy minus y is equal to x plus 1. Now by taking x on left hand side of the equation and taking y on the right hand side of the equation, we have xy minus x is equal to y plus 1. Now by dividing y minus 1 on both sides of the equation, we have x is equal to y plus 1. divided by y minus 1. So range for this function would be y such that y is not equal to 1, or more simply minus infinity to 1 and 1 to infinity. As I told you that the natural domain for this function was all the real numbers except 1. So the natural range, or simply range, for this function would be having all the numbers or all the values except 1. The last topic today to study is functions defined by piecewise. Now the example which we'll be considering here would show that the function must sometime be defined by the formula that have been piecewise together. You can see that example on the screen. If we consider a function f of x is equal to modulus x, then the piecewise domain or the function piecewise would be considered as f of x is equal to positive x if x is greater than or equal to 0, and f of x would be considered as minus x if x is less than 0. Dear student, that was all for today's program. Now let me briefly explain that what we have studied in our today's program. You can see the summary of the program on the screen. In today's program, we studied domain, range, domain determined by physical or geometric consideration, domain determined by natural restriction, domain determined by spatial restriction, some techniques for finding range, and finally the piecewise function. Dear students, hope you have enjoyed today's program. The next program will be about limits and its approaches. Till that time, Allah Hafiz.